Okay, so we're gonna do 2.6 today. Again, I'm so sorry it's out of order, but that's another reason why I'm recording it. So if you're like, can't even listen to what she's saying, so I don't want to get all mixed up, that's totally fine. Just watch it back later. Okay, what today we're doing is we're dealing with the rational, or I believe what we called in the BFF graphs, the reciprocal functions. Does anyone remember what the equation for a reciprocal graph was, or what the graph looked like?
Oh, yeah.
Yeah, Max?
The reciprocal?
Uh-huh.
So it's like a beat.
Nope, that's absolute value.
Oh, yeah. Use that.
Andrew?
It's like the curve and
Good. I call them little C's sometimes. They look like little C's. One's in quadrant 1 and one's in quadrant 3. The equation is 1 over x. And I believe you do a little bit of this in algebra 2. Am I correct? Yeah? Maybe? Okay, good. I taught algebra 2 like my first couple years I taught, but I haven't taught it since. So sometimes I'm like, I can't remember if you guys learned it or not. And I will teach it as if you never have, but it would be awesome if we all have a little bit of experience with it going into this. So I've got these two little C curves. I also have asymptotes on this graph. Does anyone remember where my asymptotes are?
So we're like gets closest to like the axis.
Uh-huh. Do you know where that happens here?
If you like right near 0.
0. Mm-hmm. Both my vertical and my horizontal asymptotes, and the sun's coming out. What a fun surprise. I have a vertical asymptote here at 0. That's not going to be a good color. Because we get closer and closer to 0, but we never cross it. Vertical asymptotes are always in terms of x. And then my horizontal asymptote, I also have one at 0. It's getting closer and closer to the y-axis, but it never ever crosses it. It's important to note that because we're gonna have vertical and horizontal asymptotes. This problem also says to find the asymptotes as well as the intercepts. So let's make a little key. I like to make a little step sheet off to the side. So what I'm gonna do is underneath that little parent function I just drew, I'm gonna write key. And these are gonna be steps to help me know what to do and when. So again, I'm just off in like the margin somewhere, wherever you want to write this out. This is going to help me remember stuff. So first thing I want to do is remember how I find my VA, my vertical asymptote. If we use the first problem as an example, does anyone know how I'd find my vertical asymptote here? Ava?
You would set the denominator
Equal to 0. Good. My vertical asymptote is where I do denominator equals 0. So in the same breath, as I'm making this key, I'm going to do those things. So I'm going to set my denominator. My vertical asymptote is going to be where x minus 3 equals 0. Let me try a little. X minus 3 equals 0. Add 3 to both sides. X is going to equal 3. X equals 3. Okay, so that's my vertical asymptote. Flannel. My flannel. All right, that's my vertical asymptote. Now horizontal asymptote. There's actually 3 situations. You did vertical. Let me see if anyone else knows. Who remembers horizontal asymptote? Or at least Max, you got me.
Yeah, okay. So if you're going off A, since they're both like not only it's like power or whatever, it
Yeah.
would just be 1.
Good. So
Use, like,
since they have the same exponent, then we look at their leading coefficients and we make a fraction of it. So I like how Max kind of started with that because there are 3 situations. Depending on what's going on, we're going to do different things. So if I have an x on top and an x on bottom with the same exponents, then it's going to be a fraction of my leading coefficient. I can't really write small enough for it to be read. Leading coefficient. And so yes, in this example, my horizontal asymptote is just 1. Now,
What is the other way around?
You thought what was the other way around?
Like, I mean, obviously it's not right. If the VA was like the denominator, or VA was the.
Oh,
it's
yeah.
like vertical. And,
That would be nice if we could remember it that way, but we can't. Good point. Okay, now there are two other cases. Do you remember what happens if my denominator has the bigger exponent? What would my y, or what would my horizontal asymptote be? Ava? 0. One way I remember that is because my parent function, remember our parent function was just 1 over x. That one has a bigger x in the denominator than it does on top, so that's always a horizontal asymptote of 0. So that's how I remember if the denominator has a bigger exponent, then it's 0. All right, and then if I have a bigger exponent on top than I do on bottom, we're gonna have to do synthetic division because that's gonna be a slant asymptote. And I don't think we'll get to that today, but just kind of like, I keep talking about it. I've done it a couple times where I keep talking about the slant asymptote. We haven't used it yet. So it'll be exciting when we finally do. Okay. Now I gotta do some intercept stuff. So we have to do our x-intercept and our y-intercept. I didn't remember how to find any of my intercepts. Ava, which one do you remember?
I think you just plug the gloss into the X.
Can you replace all the X's with 0 for the Y?
Yes, very good. For my y-intercept, we are going to plug
Oh, I don't remember.
0 in for x. Make this box a little bit bigger.
Okay, I remember.
You remember that now? Yeah. It's been a little while since we've done this. So like, let's do it up here. So let's do our y-intercept up here. I'm gonna do my y-intercept next to my horizontal asymptote because they're both y's. I get to plug 0 in for x, so I've got 0 plus 1 over 0 minus 3. So that means y is gonna equal -1/3. Okay. And then last, I've got my x-intercept. I don't remember how I find my x-intercept. This one's not really like one that I remember or one that like makes that always sense to me. You set your numerator equal to 0. If your numerator was equal to 0, 0 divided by anything will be what?
0.
0. 0. So 0 divided by anything is 0. So my x-intercept is going to be when my numerator equals 0. So in this case, it'll be -1. And if I were to go back to my key for my x-intercept, I'm going to say numerator equals 0. I'll go write that over here. X-intercept numerator equals 0. So for the vertical asymptote, you have to do the denominator equal to 0. For the horizontal asymptote, you look at your exponents. For my y-intercept, you plug 0 in for x, and then my x-intercept, my numerator is equal to 0. I like to make a little key because I want to be able to reference back to this as we go. So as I go, I'm going to say, like, let's find the asymptotes, let's find the intercepts, and I want to be able to look and see what those are. Now, since we were doing this at the same time that we were solving the first one, I have all my pieces. I'm ready to graph it, okay? So I'm going to make a little t-table or a little, I don't know, XY coordinate plane graph thing. I'm going to do my vertical asymptote, which we know vertical asymptote means that we're going up and down at 3. My little dotted line at 3. I do not think that's in the right spot. I'm going to do my horizontal asymptote at 1. So a horizontal line through y equals 1. My x-intercept is at -1, so I'm going to put a point at -1. And my y-intercept is -1/3. As long as it's somewhere between 0 and 1, I do not really care where that point is. It's just got to be somewhere between 0 and 1. All right, now we're going to finish graphing this. I've got 2 points in like essentially like the bottom like left side of my graph down here. So I'm going to draw my little C curve that goes through those 2 points and then kind of approaches my asymptotes. Do you know where the other little C goes, Ryan?
Would it be on the other side?
It'd be where?
Would it be on the other side of the sea?
Good. Would it be on the top or bottom? And on the right side, right?
Yeah.
So it'd be like in this like little quadrant over here, right? So once we set up those asymptotes, I try and think of them as little quadrants, and they always go like kind of catty corner to each other. So if one's in the bottom, then the other one's in the top. If one's on the left, then the other one's on the right. So they just got to go opposite each other. Cool. That's not too crazy, is it? All right, let's do another one. Okay, I've got this one over here. We got to do our vertical asymptote. How do I find my vertical asymptote again? Ava.
So you said it equal to 0, but this one I found actually has 2.
Okay. I said what equal to 0?
You said 2x squared minus 8
Okay.
to 0.
Good. I set my denominator equal to 0. And then what did you get x to equal?
So with that I got 2 and negative 2.
Good. I like that you did plus or minus 2. It's got to be positive 2. It's got to be negative 2. We got to try both of them. Everybody okay with that? All right, what about my horizontal asymptote? What's my horizontal asymptote? What'd you say? Yes, exactly right. Y equals 1/2. Let's do my x-intercept. What do I do to find my x-intercept again?
Numerator equals 0.
Numerator equals 0, good. So x squared minus 1 equals 0. How many of those answers am I going to have? 2 again. Positive 1 and negative 1. And then last, I've got my y-intercept. And how did I find that?
Plug in 0.
Good, plug 0 in for all my x's. 0 squared minus 1 over 2 times 0 squared minus 8. I get 1 over 8. Once I find those 4 pieces of information, I'm ready to go. I'm going to go graph my picture. Make a coordinate plane.
Right, would it be plus or minus root 1?
Well, what is square root of 1?
Oh, yeah, true.
So you're not wrong, but
My brain just can't.
I get that. It's a Monday afternoon. It's Halloween.
I was thinking of imaginary numbers and was like, no, I'm making this way too complicated.
Good. Could I graph an imaginary number on here? Like, where would I put I?
No, you can't.
Nah, we can't. And that's another good way to check yourself. If you start getting I's, like you can't graph that. So there's probably a problem. All right. Let's see. Positive 2 and negative 2 are my vertical asymptotes. Y-intercept is at 1/8, but my horizontal asymptote is at 1/2. So it's somewhere in here. And then my x-intercepts are negative 1 and positive 1. My other class seemed a little perplexed by this. Have you guys seen a reciprocal function that looks like this? With like 2 different asymptotes? Kind of. So I have 3 points that are in the middle, right? It looks like it's going to make a parabola, which makes sense because I'm always going to approach my asymptotes. So I'm going to get as close as possible to my asymptotes and stay within my line. I still have to stay within the boundary. Okay. Now I have my little graph in this middle bottom part. I'm going to have 2 little C's still, but they're going to be essentially opposite of where I am. So if I'm in the middle bottom, I'm going to have a C in the top left, and I'm going to have 1 in the top right. I have no points up there, so I just need to get as close to the asymptote as I can and just keep rolling. Even if you haven't seen that before, does that kind of make sense? Or you're like, yeah, I could see why we do that. Yeah. Okay. Are we doing good? Flip your paper over. Now, on this side, do you see something that looks like a different language?
Yeah.
Yes. This is called limit notation. I don't think any, if not many of us are familiar with this. Is that true?
I'm not.
I've seen it like.
Okay.
Yeah.
I don't know if I've shown you this at all. Limit notation using calculus. So since we are pre-calculus, I got to give you a couple things so you are not like, you know, a fish out of water when you get to calc. So let's actually graph this, and then we're going to talk about what that limit notation means. Do you want me to walk through this with you, or can you do it on your own? I'll walk through it with you. If you feel like doing it on your own, do it on your own. If not, I'll walk through it with you, and I'm going to put my work over here off to the side. So I'll do it in blue now. So I'm going to do my vertical asymptote. What do I do for my vertical asymptote?
You put the denominator to zero.
Denominator equals 0, x minus 2 equals 0, so x equals 2. All right, now I gotta do my HA, my horizontal asymptote, which is 1. I gotta do my x-intercept. How do I find that again? Ava? Numerator equals 0, x plus 3 equals 0. And then last I do my y-intercept. And how do I find that? Good, make all my x's zeros, very good. Plug 0 in for all my x's, 0 plus 3 over 0 minus 2. So y equals negative 3 halves. Now I get to graph all of those things, and they already gave me a graph, which is awesome. So I'm just gonna go plot them. I've got my vertical asymptote is at 2. I've got my horizontal asymptotes at 1. My x-intercept is at negative 3. And my y-intercept is at negative 3 halves. That's somewhere between negative 1 and negative 2. Cool. Connect your dots with my asymptotes in mind. And I sketch in the opposite quadrant. To sketch, so mine's kind of ugly, but it's okay. Yeah, Max. Yeah. Okay. Now gets to the crazy part. So now we're going to talk about this other notation. So this right here says LIM for limit. Essentially, we're talking about the limit, or like what happens with the graph. The f of x means my graph, limit of my graph. Or you can even think of it as your y, whatever phrasing makes sense in your head. Sometimes the y confuses me, so I like to think about the graph. And this x arrow infinity means as x approaches infinity. We did that notation, didn't we, as x approaches infinity? Okay. Basically, this is the exact same thing. This is basically saying y approaches what? I'm just doing it in a fancier notation. So I'm looking at my graph and I'm saying, okay, what's the limit, or what does my graph do as x gets bigger and bigger, as x approaches positive infinity? So I'm going to come over here. As x approaches positive infinity, what's my graph getting closer and closer to? To 1, right here, right? Will it ever cross that asymptote? Never. So it cannot be negative infinity. It's also not going up, so it's not positive infinity. So it's approaching that asymptote, it's approaching 1. Okay? We're doing the same thing, limit of my function as x approaches negative infinity. So this time we're going towards negative infinity on my x's. What's my graph doing as I approach negative infinity?
Approaching 1.
Approaching 1. It's still approaching that horizontal asymptote. Now, the last two are a little crazy. I do want you to cross off the 1 in letter D. It should just be 2 and then a negative as like its exponent. These little like superscripts, that plus sign means from the right. So we're coming from the right side. So we're coming from the right and going to 2. And then this negative means that we're coming from the left and we're going towards 2. And you'll find in a minute, it's interesting that we do the positive and the negative because it should be 2 different numbers. It's not the same number as we come from different directions. So we'll start from the right. So that means I'm coming from this way and going that way. So as I get closer and closer to positive 2, what's my graph doing? Going up. So what would I say there? It's approaching positive infinity. You can write normal infinity. I like to be dramatic and write a positive in front. As long as you know it's not negative, you're good. Now we're going to go from the other way. So now we're still going towards 2, but we're coming from the left. So I'm following my line of the graph from the left. What's my graph doing as I get closer and closer to 2?
Negative infinity.
Negative infinity. Very good. Why is 2 interesting? Why do you think I'm looking at 2?
Because the vertical asymptote is 2.
Good. It's my vertical asymptote. And the way that we know our reciprocal functions work, it looks different on either side of the vertical asymptote. All right, let's do another one. I think you can do this one on your own. I'll put my work off to the side, but you got this. I've got all my work up on the board now. Go ahead and check your work, or feel free to look up, see it, how it's doing. Okay, I'm gonna go graph it. All right, there's my graph. You doing okay with that? All right, now I want you to take a minute, see if you can do the limit notations on your own. We'll do it together in like 2 seconds, but try the limit notations on your own first. Okay. So the first one says limit of f of x as x approaches positive infinity. So as x gets bigger and bigger, what is my graph getting closer and closer to? Yeah, Sophia? 2. What about as we go from the negative direction? What's my graph getting closer and closer to? 2. Wait, time out. Do you guys notice a trend here?
It's
The same.
It's the same. And what is it the same thing as? Which one? Horizontal. Is that true for the one above, where both the positive infinity and the negative infinity are the same?
Yeah.
Where they're the same as the horizontal asymptote? Love a little trend. So that's something I would make note. It has to approach the horizontal asymptote. That's how our graph works. It doesn't go like this. It always approaches the asymptote. So it will always be on positive and negative ends. It will be whatever your horizontal asymptote is. Now, as we approach -2 from the right-hand side, so I'm coming from this way, my graph is doing what? Negative infinity. And then vice versa, if I approach from the left-hand side, what is my graph doing? Positive infinity. Do you also notice on the 2 above when we were approaching the vertical asymptotes, we were positive or negative infinity? Same thing up here, positive or negative infinity. It's not always the same one in the same order, it's just those 2. Okay, I've got one more I want to do. Can you guys buckle up for one more problem? Okay. Before I do anything, we haven't had to do this yet, but we're going to have to simplify. We're going to have to factor the numerator and the denominator. So let's do that. We're going to start this problem by factoring. X squared minus 9, what does that factor down to be? X plus 3, x minus 3. What about 3x plus 9? Is there a common factor there?
Yes, you could go through 3 and then this is x plus 3, and then you could cancel those out from the numerator and denominator.
Very good. If you have a common factor on top and bottom, you get to cancel it out. Do you remember what happens to my canceled term? Do you know what that does to my graph? Can you remember? We haven't had one yet.
Just because your
Kind of. Ryan? It's a hole. Very good. It's an open circle. It's a hole. So a hole happens from your canceled, I don't know if canceled has 1 or 2 L's, but pretend like I spelled it right. From your canceled factors. So whatever your canceled factors are, that's going to make a hole. We haven't had to cancel any factors up to this point, so we haven't had any holes. But now I'm going to have a hole at x equals what? -3. Okay, now that leaves my graph, my equation, at x minus 3 over 3. Is that still going to be a reciprocal function? What would my vertical asymptote be? I wouldn't have one. And then it just starts getting messy. I'm going to argue, looking at just this is not going to be a reciprocal function. Kevin, do you know what it would be?
Standard.
It would be what?
Would it be a standard?
We could say it's in standard form, but like what shape does it make? Make a V? Does it make a parabola? Andrew, what are you thinking?
regular line.
Just a regular line. And I think that's what you meant by standard, but I was looking for the word line. Anytime you have an x to the first power and nothing on the denominator, that's a line. You could have simplified this to be 1 over 3x minus -3 divided by 3 is 1. If you looked at this, you'd be like, oh yeah, that's kid stuff. That's algebra 1. That is a line. I can graph that. The only thing is that we're going to have a hole at x equals -3. So I'm going to go to -1. I'm going to go up 1 over 3. I'm going to go down 1. I'm going to over 3. Now that happens to be at my -3 point, so I have to make that an open circle. So I'm going to do my line through them. I'm always really terrible at these things. That looks a little bit better. So it's a line with an open circle right there. And we found that by simplifying and finding a canceled value, which what became our whole. There are 3 examples we didn't get to. We'll get to those on Friday or whenever the next class I'm ready to teach you stuff on this is. This homework will not be due until next week. This is not on your test on Thursday. It is not on your test on Thursday. It will be on the next test, but not yet.
I'm so daunting with this.
You do not have any homework. Woo! I'll stop this.